So now we've seen how to add and delete documents, but when we do something like this, our UI is not automatically updating. It would be nice if we could keep our UI or template in sync with our Firestore data. Now, a Firestore database has real-time capabilities to do this. And by that, I mean we can set up a real-time listener in our JavaScript code, and that listener will actively listen at all times to our database collection. Then when something changes in the collection, like a new document added or a document removed, it will get that update back and we can update the UI with it. Now, this is one of the best advantages of using Firestore as a database. So let's see this in action. The first thing we need to do is get rid of all of this stuff where we actually get the documents initially, because this is a one-time retrieval. It just gets them at the start, and what we want to do is get them every time there's some kind of changes. So let's first of all delete all that. Now what we want to do is set up a real-time listener. Again, we need a reference to the collection, so we say db.collection, and we pass in as an argument the collection we want a reference to, which is recipes. Then to set up a real-time listener, we use a method called onSnapshot. Now this fires a callback function and takes in the snapshot when this happens. Now what is happening here? Well, every time the collection changes in any way, Firestore takes a snapshot of that collection, and the snapshot represents the state of that collection at that moment in time. So we're saying here on snapshot, which means every time you take a snapshot, or every time there is a change in the database and you take a snapshot, then fire this callback function and send us that snapshot. And this snapshot is going to contain information about the state of the collection at that moment in time. And on that snapshot, we can see all the data changes. So let me just now console.log this to the console and save it. Then have a look over here. So now we see right here, when we first load the web page, we get this initial snapshot. So if we open this, we can see down here, we have the docs, and that's an array of 3 things right here. Now also, if we open up this proto, we can see this method called docChanges. Now this method, docChanges, gets us all the changes in the database that's happened. So every time there's a change, it sends us this snapshot, and we can use this method to see the changes inside the Firestore database. So let me just use this and log out the results. I'm going to say snapshot.docChanges like so. Save that and refresh, and now we can see this array. So this is the initial snapshot document changes. So if we expand this, we can see 3 objects, and each object represents a single change. So since this is our first snapshot and we had nothing before it, it considers the initial documents inside the collection that we already have, over here, as changes when we first load the application. Now these changes are seen as added documents, hence the type value, meaning since the last snapshot, these documents have been added. Now, like I just said, this is our first snapshot, which is why it considers these changes to be added since our last one, because we didn't have one before. So initially, when we first load an application and use a real-time listener, it sends us an initial snapshot with 3 changes, or however many documents we have in here, that number of changes, and each one of those changes is considered added, because it's the first time we have seen them since we've loaded the page. Now, every time the data changes after this, we'll also see a new snapshot. And we'll also see a new document change, because every time we get a snapshot now, we're going to log out the document changes. So if I now try to add something, I'm just going to say test and press enter. Now I can see a new array with that document change. So we can see it's an added type. Now, if I was to go over here and now delete one, let me just find the one I just added, which is here. I'm going to now delete this by going up here and saying delete document. Now, when that happens, because we're listening to it, we get another change. And we can see now the type is removed. So now every time something happens, we're being notified that that is happening inside this callback right here. So what we could do is take that information and then apply it to our UI. So every time we add something, we call the function up here to add that recipe to the UI. Every time something is removed, we call a function to remove that from the UI, and we need to make that function later. But the first thing we need to do is check the type of document changes we have in here. Initially, they're all added, but every time thereafter, it could be added or removed. Now, if it's added, we want to add a recipe. If it's removed, we want to remove a recipe. So let us first of all delete this. Then I'm going to say snapshot.docChanges, which is all of the changes we just saw. That's a function. This gets us an array of the document changes. And what we're going to do is cycle through these using for each, because every time we get something back, it's an array. So we need to cycle through those using for each, even though sometimes there's only one change. So we're doing this and we're going to fire a function for each one. Now we take that individual change object in each time. You can call this what you want, by the way. I just call it change because it represents a document change. And what I want to do is get that document, because at the minute, if I just say console.log, the change, then we just see the change objects, these things. I actually want this property right here, the doc property, because that gets us the document reference. So what I'm going to do is say const doc is equal to the change dot doc, and that gets us the actual document. So if I now say console.log, the doc, this is the actual document rather than just the change. So we have a reference to that document. Then we need to check the change type. Is it added or is it removed? So we'll say if, and then the change dot type, because remember we have on this change a type property, and if that is equal to added, first of all, this is when we want to add that document, and we want to call this add a recipe function. So at this point, what we need to do is come down here and say add recipe, and we want to pass in the doc.data as the first parameter, and that gets us the actual recipe, so the things with the title and the created app properties on it. As the second argument, we want to pass in the ID, so that is doc.id, and remember doc we get from here. Okay, so that's the first thing. So now if I was to save this, because we're getting these initial snapshots for the first items in it and they're all of type added, then we're going to call add recipe for each one of those documents and pass in the data and the ID, and it should output those to the browser. So let me save it and preview, and now we can see them right here. Now we need to do the same thing for deleted. So now we'll say else if, and then change.type is now equal to removed. Then we want to remove that document. Now how are we going to do that? Well, we're going to create a new function called delete recipe to do that. So let me say const delete recipe, set it equal to an arrow function, and inside this arrow function we want to delete a recipe. Now when we call this function, we need to pass in the ID of whatever document we want to remove from the DOM. Remember, we're not actually removing it from the Firestore database. That's already happened. We're deleting it from the Firestore database down here. And when that happens and we get that change back, which is of type removed, now we just want to delete it from the template, the UI. That's all we're doing here. So if we pass in the ID right here and take it as a parameter, then what we could do is look inside our list for whatever li tag has that ID right here. If it has the ID, then we can remove it from the DOM. So what I'm going to do first of all is get a reference to all of the li tags. I'm going to say const recipes is equal to document.query selector all, because we want all of them, and we want all of the li tags on the page. So that gets us a collection of all of these li tags. Then we want to cycle through those. So to do that, we'll say recipes.forEach, and then for each item, and we'll call each one a recipe, we want to fire a function. Now in this function, we want to check if this particular recipe, if this li tag has a data ID attribute equal to whatever ID we pass in. If it does have the same ID, then we want to remove that recipe from the DOM. Does that make sense? So let's do that. Let's do this if check. We'll say if, and then the recipe, which we currently are cycling over, if that dot get attribute, and the attribute we want is the data-id, so we're getting the ID of that li tag, which is this thing over here. And if that is equal to this ID we pass in to the function, so we'll say triple equals to ID, then we want to remove it from the DOM. So we'll take that recipe, which is the li tag, and use the remove method to remove it from the DOM. So now we're doing this, we need to call this function from down here if the change type is removed. So what I'm going to say down here is delete recipe and pass in the ID, which is doc.id. So let's save this and give this a whirl. Come over to the browser. And first of all, if I add something, I'm going to say test and add. We can see that output right here. And now if I delete something, then we can see it delete in real time. So now this is all working thanks to this real-time listener right here, where we get a snapshot every time something changes, and then we can cycle through all of those changes using for each. For each change, we can check the type of change. If it's added, then we can add the recipe to the UI. If it's removed, then we can delete the recipe from the UI.